All right, we need to simplify this radical rational expression. The first thing I'm going to do is just simplify the rational part, this fraction here. I do that by canceling any common factors. For instance, I'm going to cancel 2 of these n's with 2 of the n's on top, and I'm left with 7 n's on top or in the numerator. And then 4 of the a's with 4 of the a's in the denominator, and what I'll get is our 9 a's left. By the way, I would also cancel any common factors between the 14 and 11, but 11's prime and doesn't go into 14, so there's nothing there. But you'll see examples where that will happen too. Okay, so what do I have? I have 11 n to the 7th up in the numerator, and it's a 14 n to the 11 up in the numerator, and I have 11 a to the 9th in the denominator. And what I'm also going to do is I'm going to split the radical over the numerator and the denominator, and I'll tell you why in a second. I just want to give a quick concept check on that. We know when we simplify radicals that the product rule exists, that when we have 2 things being multiplied inside the radical of any index, we can split up that radical between those 2 factors. There are some issues with negative and positive values and even indices, but let's not worry about that. My point is you can split up a radical like that, but you can also, in the same way, split up a radical over a fraction or over 2 values being divided like this. And this is the rule for square roots that I'm using over here. Okay, back to the action. What am I going to do next? The next thing I'm going to do is I'm going to simplify each of these radicals independently. I'm not going to show you all the steps for this. Many of you are experts at this already. But on top, there are no perfect square factors in the coefficient. I'm going to pull out an n to the 6th. That gets square rooted and becomes an n to the 3rd on the outside. Leaves me with a 14n. In the denominator, I got an a to the 8th I'm going to pull out and square root, which is going to give me an a to the, nope, that's not an a to the 8th. That's going to be square rooted, and it will end up being an a to the 4th. And then I have an 11a. Okay, take a second to verify that you agree with that before we move forward. That is, I'd say 75% of the work we need to do on this problem. The last thing that we're going to do is we're going to rationalize the denominator. The issue here is we can't leave our answer with a radical in the denominator, and there are real reasons for this that we won't cover, but they come up in future higher level mathematics. What we need to do now is to simplify this fraction in a way that keeps it equivalent, but it gives us an answer that doesn't have anything in the denominator, or doesn't have a radical in the denominator. And this is the beautiful move that we're going to do, and with square roots it always looks like this. At this point, what I'm going to do is multiply this fraction by a factor of 1. I can always do this. The factor of 1 in this case is going to be that exactly the same square root that I see right there, a square root of 11a, and I do that in the top and then the bottom, numerator and denominator. The result of that action is this. In the numerator, I'm going to have an n cubed, and then I get 14 times 11, which is going to be 151. And then I have an a and an n factor there, so I'll just write 151a n in that order. And then what happens in the denominator is quite magical, and it's why I multiplied by the square root of 11a. On the side, I'll just show what's going to happen. Actually, let me say this. After you multiply all this together, what I'm going to have is 11a to the 5th without any square root. That was the reason that I multiplied by this, but let's talk about what the heck happened between those 2 steps. Well, with just the radical part, square root of 11a times the square root of 11a, what I would get from that is the square root of 11 squared times a squared. But the square root of that is easily done because these are both have an exponent of 2. Or you can think about, I'm just going to divide those exponents by 2 to take the square root. The result of that multiplication is 11a. which is always the case actually. If you multiply two square roots together that are identical, the result is always just the inner part of the square root. So what happened over here? Well, when I multiplied the square root of 11a times the square root of 11a, what I got was 11a. Then I multiplied that by the a to the fourth. That resulted in 11a to the fifth. This right here, this glorious, still crazy looking thing, but mathematically completely simplified, is our final answer. Because the radical is simplified as possible and the denominator does not contain any radical. That's the entire goal of these division of radicals.